Okay, now what about the sun when it's going over the horizon? In fact, all the way through the day, the sun doesn't change its angular size. If the sun was just going away from us, it would get smaller and smaller and smaller and smaller. But guess what? We would always be able to see it. If I put a lamp on down the bottom of my garden, or even a small torch down the bottom of my garden, I'm going to see the light in the dark. So even if it's dark for me, and it's light down there, the bottom of the garden, I'm going to see it. I'm going to see the light. Now, you all know that we can see stars. Well, think about this. You're looking at stars. Look up north, towards the north, and look at the stars. And you can see them. Are they bigger than the sun? How come you can see those stars that are right up there in the north? And yet, when the sun goes away from you, you can't see it anymore. What happens? You reckon the sun's gone away, it's reached its vanishing point. This is what I hear all the time, by the way, so I'm not making this up. The sun's gone through this vanishing point, so it's gone away in the distance, so we can't see it. Why can't we see it? Why can't we see the star that's further away? Because remember, if you believe in this dome thing, and we're looking at the star over there on the other side of the dome, in the north, because this is flat, remember this place that you reckon? So we're looking at the star on the other side of the dome, right? You know, like where the sun's heading. Well, why is it we can't see the sun anymore, but we can see that star on the other bloody side? Is that star on the other bloody side bigger than the sun? Wouldn't the people who are in the north look at that and say, wow, that's one bloody big star? It's bigger than the sun. How did you get to be an adult and think that and not figure that out? That's just ridiculous. If the place was flat, you'd always see the sun, even if it was just the same size as a star. Don't tell me it would just vanish. And yet, you can see a star further away from it, even further. So the sun's not even got to as far as the other side of the dome, but you can see the star over there. You get my meaning? When are you going to start thinking about these models that you put together in your mind? And don't tell me you haven't got a model. Well, you strictly haven't got a model, but don't tell me you haven't got a thought about this. Don't say, look, the earth is flat, and I haven't given it a second thought about what happens to the sun. And by the way, this is another thing that I hear. Dell does this a bit. Okay, he says, he's got this analogy. If you look up at the sky and you see the bulb, how does that tell you what shape the ground is, the floor is? That's a false equivalence. Of course, looking up at the sky tells us a lot about the shape of the earth. Look at all this. We can tell the shape of the earth by looking at the sun, because we can see how the sun goes, the earth goes around the sun. And from that, we can look at the planets and we can see how they move. And we look at that and we say, well, the earth must be a sphere for all that to happen. So don't tell me that they balls and this is a billiard table. What a load of rot. Grow up. Now, let's carry on. All right, what else is there? Okay, so again, I'll just reiterate, the sun doesn't speed up for Australians. It goes the same as yours, up in the north. And by the way, the people in Russia get to see the same sun at the same time. Okay? And by your model, the sun for us would be going 3 times faster. Well, it doesn't. And strange, how the hell does it go 3 times faster for us, slower for them, at the same time? This is one hell of a strange sun. Forget about the fact that this sun would have to have with it a magic lampshade, because it's supposed to shine on half of the earth at once. So how the hell does that happen? How the hell do the people who are near the center of this magic lampshade who are standing in the dark, not see the sun? They don't even have to look at the other side of this dome. They're halfway in the middle of it. They're in Kenya, like on the equator. They don't see the sun. They're in the dark. They have got such a short distance to look. Why can't they see the sun? Did you even think of that? No. You know why you don't think of that? Because you have your little moments where you think, I've got a little thing here. I can see 23 miles to some peak. Ranty's just doing one now. I haven't had a chance to look at it, but I will, and I'll have a bit of a discussion on it. It says you can, from 12 feet up, you can see 23 miles. You've got to figure out an explanation for that. And the explanation isn't that the earth is flat, because for all sorts of other reasons, the earth is not flat. Okay? That's not how science works. We don't find an anomaly and then throw the whole thing away, throw all the science that we've ever learnt away because we found some anomaly. We try and figure out what's wrong with that anomaly. Why is it an anomaly? What's strange about this particular thing that makes it an anomaly? We don't just say, whoa, all the science is wrong. All thousands of years of science is all wrong. Never mind that we've been using these thousands of years of science to do useful things in our lives. There's this word coherence. That means your evidences have to be coherent with your hypothesis. You can't pick something that works or looks like it works and just ignore something that doesn't work. They both have to work at the same time. Day and night have to work with seasons. If you think the sun's going away from you on your magic lampshade, okay. But then that stuffs up seasons, doesn't it? And if it stuffs up seasons, it's not coherent. If it's not coherent, then it's not a model you can rely on. And there's absolutely not one single thing with the spherical model that's not coherent. Every single thing, every single angle that you look at is coherent with the next one. Unsurprisingly, because it is a sphere. Okay, let me reiterate. So I wrote down a few things. The what if it was flat? So let's just go through them. First of all, what if it was flat? The angular size of the sun, as I said before, would change. It would start off really, really small in the east, go across the day where it will be the biggest because it's over your head. That's as big as it's going to get. And then get smaller and smaller and smaller until it's in the distance. And remember what I said. Forget about this idea that you won't be able to see it. Because if it was flat, you would, because you can see the star that's even further away than the sun. So why can't you see the sun if you can see the star? Okay, done with that. Okay, day and night, that doesn't work on your flat Earth thing, or it's a plane, but I don't know what it is. This luminary, I don't know what it is. Well, I've already demonstrated to you that we do know what it is, okay? Right? You don't know what it is, okay? Because you haven't bothered to look it up. You've just listened to those gurus who are taking money and they don't even believe it themselves, okay? Dell, he's been looking at this for years. He's invested in this. It's his persona. It's a big deal for him to let this go and say, yep, guys, I was wrong. Yeah. It doesn't make sense that it's a plane. Okay? That's not going to happen. There's so much invested in that. And of course, he and others would say, well, I'm so invested in the idea that it's a sphere. Well, of course I am. But I'm not just invested in it because I've got a hypothesis. I don't really know what shape it is, but I'm just saying it's not a globe. I'm way beyond that in my investment of it. I use the fact that it's a sphere. In everyday life, those dishes on the roof of your house is pointing to a satellite. The satellite's not on a balloon, where balloons, have like a 24-hour lifespan. It's not on a balloon that can just wander off, in the breeze, or not breeze, but just, nothing to tether it to the ground. It's going to move. You know what happens if you get your dish and move it 2 or 3 inches out of alignment? You think you're going to get your TV signal? Well, so that's a good point to actually raise, because some of you flat earth people are saying, well, that dish, that's not a satellite dish, that's pointing to a ground-based station. Even though it's pointing up in the air, that would be one hell of a ground-based station, yeah? Yeah. How tall are these ground-based stations that you're talking about? Show me one that tall. Because let's see, if the thing is pointing up 45 degrees and the ground-based station, I don't know, is a few miles away, that would be a bloody tall station, right? Wouldn't it? Just think about that. Think about a triangle that's 3, 4, 5. Okay, so 3 along, 4 up. I'll give you the benefit. Put the 4 up, okay, and the 5 is the hypotenuse. Okay, all right. So now you think about if it was. Think it's a 45. If it's 45, it would be an equal distance, yeah, up and along. Okay, because that would be 45 degrees, 90 degrees. That means those two sides are equal, right? Okay, imagine how far away, how high it must be. So if the thing is 10 miles away from me, which isn't that far on the ground, it's 10 miles up in the sky, right? Have you seen a tower that's 10 miles up in the sky? Think. It can't be a tower. Think. Okay. All right, so what else did we get? Season's not going to work. Speed is dumb. You're suggesting that the speed's going to be 3 times faster in Australia than it is for the Russians. So let me think. I worked it out actually. I'll be lucky in your speed to see the sun pass over my city. I'd be lucky to get an hour of sunlight at the speed that it would need to travel. So I'm in Melbourne. I'd get up in the morning. Ooh, there comes the sun. I'd physically be able to trace the sun like this with my hand across the sky, across the city of Melbourne, and then it'd be gone. How are you not thinking that? Why doesn't that cross your mind? That's ridiculous. Okay. Two places, different speeds. Radiation. I think we've said enough about radiation, right? If the sun was anywhere near without this magnetic field to look after us, you'd be fried. In fact, there would be no life on this planet. Okay? The sun's been there a lot longer than any living creature. And even if you believe what the Bible says, the sun was there before the people and the animals. Well, which came first, the sun or the moon? If the sun came first, and then the moon, and then the animals, not much would have happened after that, because all the animals and all the people would have died. So that's ridiculous. You think maybe the radiation came afterwards? Think. Okay. Let's see. Would we be able to see the sun as we see the stars? I think I've said that enough. Okay. All right, so if you can't remember all the stuff I've said, just go over the video a few times. All right. I'm being a bit harsh because I have been listening to the nonsense. Okay? And some of you are teaching your kids this nonsense. Are you actually showing your kids the problems? Are you giving your kids a chance to think about the problems like I've explained tonight? Do you think it's fair if you don't? I know some of you have little kids. I'll bet you any money you're telling them that the earth is flat. Just like you tell all those people on the street. They go up to you, you ask them questions, you blindside them. You tell them that the earth is flat. Maybe they believe you, and then they start telling their kids that the earth is flat. And none of them think about any of this, right? Because you didn't think of any of this. Or maybe you did. Or maybe no evidence will do it for you. Okay, there's a lot more to go. Magnetism is next. Okay? All right, folks. I don't mean to scold you all. Okay? So if you like my video, press the like button, press the subscribe button, and I'll do some more. Cheers. Flatties, think.